Hi guys, welcome to our channel of Sciences and Mathematics. Today we are going to look at a summary of the functional groups of organic compounds that we have discussed in our various videos. So for today we are just basically going to look at the part of these organic molecules which of course dictates their chemical properties specifically and even their physical properties. So in that case we are going to look at a few examples of what we have already discussed and try to see the difference and similarities between them. So for that case, thank you and welcome. So as we have already said, we are going to look at functional groups in organic compounds. And as we said that organic compounds are compounds which are basically made up of carbon and some of the elements in the periodic table that we discussed about, that is oxygen, nitrogen, and etc. So in that case, we're going to look at this specific class of organic compounds and try to see that the functional group actually consists of a particular range of elements which tend to repeat itself. Maybe for instance like a hydrogen that we are seeing here, and there's some functional groups that may contain oxygen and nitrogen. So these specific elements in the periodic table are centrally located, and as we said that the tendency of an element either to gain electrons in the valence shells or lose the electrons in the valence shell in order to attain stability. This is the one that dictates the properties and chemical reactions of elements. So in that case, most of the elements or some of the elements which are located at the extreme right and left of the periodic table tend to display some kind of reactivity, except the noble elements. And we're going to see that aspect when we're discussing about the periodic table and the trends. So in that case, for today, we're just going to look at the functional groups and try to see some of the similarities which may appear between different functional groups, and then try to see how they are going to be applied as we come across different kind of chemicals or compounds in our different discussions. So for today, we are going to discuss about the alkanes, ranging from the alkanes to the amides. So in that case, alkanes, we said, is a group of organic compounds that consists of a carbon-carbon bond which is bonded covalently using a single bond to either hydrogen or other carbons. So in that case, the functional group of alkanes is made up of carbon-carbon bond which is bonded to hydrogen using a single covalent bond. So in that case, the functional group for alkanes is not it's non-existent actually. Non-existent means that it does not have a functional group. So in that case, its range of reactions is limited, and which means of course alkanes have minimal applications. We said that we can be able to achieve different kind of compounds by attaining maybe or trying to manipulate its structural formula, and etc. So we are going to look at that when we are going to discuss about the reactions of these organic compounds. So in that case, there is also another group that is known as alkenes. Alkenes is a group of hydrocarbons which are made up of a carbon-carbon bond, which are double bonded, which means they have two double bonds between the carbon-carbon bond. Now, alkenes together with alkynes form a group of organic compounds that we call unsaturated organic compounds, whereas alkanes form saturated compounds. Now, the difference between the two is that saturated compounds consist of a single carbon-carbon bond and is covalently bonded to other elements using a single bond, whereas the carbon-carbon bond in both alkenes and alkynes can either consist of a double bond for alkenes or a triple bond for alkynes. Now, the functional group for alkenes is a carbon-carbon bond that we have said that consists of a double bond. An example of that is an element we have drawn for that case here. It's known as ethynyl ethylene, and basically that's just an element with two, a compound with two carbon atoms which are double bonded. And for alkynes, this one is a carbon-carbon bond with a triple bond, and this element, as we can see, is known as acetylene or ethine. Now, the functional group for alkynes It's a carbon-carbon triple bond, as we have said. Another group of or class of organic compounds is aromatic compounds, and this basically consists of benzene and its, of course, similar compounds, or similar groups of benzene-like compounds, like the naphthalene. But for this case, of course, we're basically looking at the functional group. So it's a cyclic kind of hydrocarbon, a cyclic kind of organic compounds that consist of alternating single and double bonds between the carbon atoms. Now for this case, this element is known as benzene, and it basically consists of 6 carbon atoms which are bonded alternatively single and double bond, and then there is a hydrogen atoms which have been bonded to the each and every carbon. So the formula for this one will be C6H6. We shall see other examples of that. And then we have what we call alcohol. Alcohol is also another class of organic compounds. Now the functional group for alcohol is C, which is bonded to OH. Of course, we shall also look at this class of organic compounds. And there's going to be a difference between this kind of OH and then the OH or the H that we're going to see in carboxylic acids, which of course at this particular point, when we are drawing the molecular structure or the expanded formula for these two kind of compounds, we're going to see the difference that this consists, as it is an acid, it consists of a proton, whereas this one consists of a OH group. So in that case, this member has got a functional group that appears like this, and then the first, we can see there is a member here that is known as ethyl alcohol. So this one consists of a carbon-carbon bond with a OH bonded to it. So the next class is ethers, and ethers is a group of organic compounds that consist of an oxygen which is bonded covalently to 2 carbon atoms. And we're going to see that later. We are going to demonstrate or illustrate this kind of carbons using a capital R, which denotes a radical group, of course. Radical groups are groups which are not participating in a chemical reaction. So they basically are represented by capital letter R. So in any case, for this, if we were to write, we can just write an R which can substitute this particular carbon here and this one. So this one can be R, and then R prime if it's a different group. So in that case, that's a functional group for ethers. And the first one is the one that we have demonstrated there can be named as methoxy ethene. Of course, we're going to look at how these two different parts participate in naming and the priorities or the order in which we're going to name this. So as well, this one, as we said, there is a IUPAC naming system, and there are common names which can be able to be used just in case of in place of the IUPAC system, which are generally accepted by the community of scientists or the naming organization. So in that case, that is for ethers. Now there's another class that is known as aldehyde. So as we have seen from the different range of class of organic compounds that you have discussed, this particular oxygen is singly bonded to the carbon. But there's another range of organic compounds that we are going to see that the oxygen group has been bonded like that one, this one, that one, and this one, excluding this. So in that case, we're going to see that these functional groups consist of a carbon that has been bonded to oxygen using double bonds, and there's a specific name that we're going to use to refer to that. Now for aldehydes, it's a carbon atom that has been bonded to doubly bonded to oxygen and consists of hydrogen. At this particular point whereby we do not have of course an element or a compound, we're going to see that the radical groups that we were talking about, using the line drawing format, we can just use this stroke to represent a radical group, of course, which means there's an R at that particular point. So in this case, if we try to look at this example, this part of the molecule is this one, and then there's a methyl group at this particular point. So that can be represented as just a stroke. So in that case, the name of this compound is known as ethanol, or acetaldehyde. So the class of organic compounds that consist of this part of a molecule is known as aldehydes. So then we have what we call ketones. Now the difference between aldehydes, the functional group for aldehydes and ketones, is that for ketones, there's no hydrogen at this particular point, but in between the carbon that is bonded to oxygen, or besides the sides of the carbon that is bonded to oxygen on both sides, we have what we call radicals. That is, can be R prime. So that's for the functional group for ketones. So in this case, we have an R with a similar R here, which is a methyl, of course. So for this case, because of naming, we will see there's a different or a characteristic way in which we are going to name ketones. And this is basically its functional group, in that there's a radical group at this point and then this one, which are, of course, encircling the carbon-oxygen group. And then for carboxylic acids, the functional group for this, remember, as we have said, this is an acid, and we're going to see at the topic from the definition of an acid and a base. We say that an acid is a proton donor. So for that case, there's a proton which is H positive, that is at this particular point. So which means this other section of the molecule is a negative one. So for this case, this is a proton, and they say that we're going to see the difference between this one and for alcohols, in that their structural representation is different, because this is an acid that consists of a proton. So in this case, for carboxylic acid, there's a carbon that is double bonded to oxygen, and there's a O which is bonded to that proton, of course, which forms a functional group for carboxylic acids. So as I said, they can be a radical group at this point. For that case, if there is a methyl, then we can have the name for that example of carboxylic acid as ethanoic acid or acetic acid. Then we can move to the next class, which is esters. Esters are a group of organic compounds which are formed by the reaction between aldehydes, the reaction between alcohols and carboxylic acids. So we are also going to see that one when we perform different reactions, maybe, which is a formation of esters. But the functional group for esters consists of this carbon that we have demonstrated here, together with, of course, it consists of this section of carboxylic acid, and a substitution here which has replaced the hydrogen that we have talked about here. We shall see that one in the reaction. So for that case, if we can give a member that consists of this functional group which we have stated here, then we can have an example that goes by the name methyl ethanoate, or methyl acetate for the common name. So then basically we are going to also look at the amines. And an amine is a group of organic compounds that consist of nitrogen. We talked about some elements which appears in between the two extremes of a periodic table, like nitrogen, oxygen, carbon, so which forms, or which basically could rather consider to be bonded covalently with other elements instead of taking part in a chemical reaction. So in that case, they form a large part of organic compounds, and one of them we said is nitrogen. So in that case, nitrogen, this is amines is a class of organic compounds that consist of a radical group. As I said, that there can be a radical at this particular point, or maybe hydrogen as this. So in that case, there's a radical which has been bonded to the nitrogen, and hydrogen at those particular points. So we're going to see also that there are some degree of substitution which can occur here, which can give the amines, amides, etc. a different name, or maybe concerning that degree of substitution. We're going to see that that's for the first degree, second degree, and third degree amines. That one can as well occur to alcohols and other class of organic compounds. But for that case, this is the functional group, and we can give an example there for methyl amine. And then for amides, these are this kind of carbon that has been bonded to nitrogen, and these ones are radicals at this point, this one and this one. We can maybe denote this one by R prime, R prime, prime. So that case, we can as well have it represented by either hydrogen at these particular points. So example of that is ethanolamide, or for a common name, acetamide. So generally, these functional groups are very important, and we can see that they are different categories. But of course, there's this carbon which I've been mentioning, that the carbon that has been doubly bonded to oxygen. We refer to this as a carbonyl carbon. So whenever we're going to mention the term carbonyl carbon in our discussion, let this one appear in our mind, that is a carbon which has been doubly bonded to oxygen. So in that case, this is a range of functional groups that we have already discussed in various aspects, especially dealing with the nomenclature. But for today, we were just going to look at a summary of it, so that in any case we need to remind ourselves, it will be good or important for us to come back to these videos and try to see which kind of or class of organic compounds are we dealing with, how its functional groups has taken place maybe in a, or has influenced a reaction in one way or another. So for a recap, remember that this one is a saturated hydrocarbon, because all the possible substitution at these particular points of the carbon have been done. And then for this and this one, they are referred together as unsaturated hydrocarbons. And then this is aromatic hydrocarbon, it's a cyclic one. And then for alcohols, I've said there's a difference between the OH that appears here and here. We are going to discuss about that for ethers. And then there's a carbonyl carbon that is bonded at these specific functional groups, and that is for the functional groups. So for that case, that is it for today. But in that case, I've just used the color coding, like the nitrogen here, hydrogen for blue, oxygen for red, and then for bonding I've used black. And then for the carbon atoms, I've used green intentionally, so that we are able to differentiate between different functional groups. So that is it for today. So thank you very much. I felt that it is okay or important for us to have this summary, so that in any case we need to come back and do a reference, it will be easier for us. So thanks guys for today. That is it. Let's meet in some of other topics, and also let's remind ourselves that it is the functional groups that dictate the chemical reaction. So that one, it will be easier for us to be able to represent different organic reactions that we're going to see in other videos. So for today, thank you, welcome, and may God bless you. Bye.